So what I'd like to do now is talk to you about a really exciting project. It's our Cellulosic Sugars project. And what I'll do, I'll take a little bit different approach to this particular one. I'll give you an overview of our project, talk to you about the process we took to complete this project, as well as some of the recommendations coming out of the project. And then what I thought I'd do is just share with you some of the observations and learnings that we've experienced as we were going through our evaluations. And of course, we'll talk about what's next. So what's the value proposition for cellulosic materials? It's fairly large. You're talking about in the tens of billions of dollars of addressable market space in both products derived from cellulose, hemicellulose, and lignin. You know, our vision is to have an operating agriculture, biomass, and end product supply chain by 2020. You think about our project development, I mean, we started off really early in 2013 with a feasibility study thinking about, does this make sense? Is it right? What is our approach to make this vision become a reality? And over the past couple of years, we worked really hard with 19 different technology providers who have the in-home technology to take biomass into the individual cellulosic products. We've worked with different farmer groups. We worked with Charlie's group with his project, who really started by evaluating at the farm level the economics and the agronomics associated with biomass harvesting. And then most recently, the Cellulosic Sugar Producers Co-op, another long name, and Comet, nice short name, have announced their intention to build Canada's first cellulosic sugar plant. So again, this is a tremendous collaboration project. There are a lot of people involved in the project, and in February we just finished our technology selection stage, and then working with Comet and the Cellulosic Producers Co-op, we're working to help them develop this project with a goal of building a new plant and seeing new successes from that plant. In our approach of managing information flow, we set up a steering team comprised of 3 companies that formed our market group, and those 3 companies are Bioamber and JBL for short, and IGPC. We had 3 representatives from the supply group, which are really 3 people who own farms and grow corn, who will one day be suppliers of feedstock for the plant. We had 3 people from BIC, 1 from OFA, and we had some observers on our steering team who were some of the funding partners for our project. Technology development is a very interesting thing, and we also respect the level of confidentiality required to maintain your competitive edge as you develop your technology. So throughout the project, we maintained very strict firewalls of information. The technology developers and the people we were dealing with, they were blind to who they were working with, but they all knew they were working with us, and that takes a tremendous amount of trust, and we respected that trust and worked with them to be where we are today. And just now we're starting to, with their permission, disclose who they are with the right partners. So if you ask me any questions about technology or economics, I can't tell you. So what are the results? So what we did is we looked at 19 different technologies, and we validated the economics from the farm to the end products of harvesting up to 250 tons of stover to produce up to 125 tons of cellulosic product. And we took the technologies, we made the recommendations to the co-op, and with the co-op, for the first project, they chose to work with the people from Comet to build that first plant. So, as part of our selection criteria, we worked with our steering team committee to develop a set of criteria which we applied to every single project. You can see there for yourself. The key things here was it had to be economically viable, it had to be doable, had to demonstrate sustainability, and produce products that you can sell into the market. In our evaluation, we framed it, our business model on a DCF, discounted cash flow model, looking at the technology and all the financing components that goes with it, and we enveloped the entire process from the farm to the very end product. We employed a stage gate process. We started off with 19, rolled it down to about half to about 8. We visited those plants, did high-level mass material balances and high-level economics. And then in our third stage, we picked 4 companies, and with the project that Charlie was leading, we had harvested an equivalent of 240 acres of stover, and asked each of these companies, take the stover, show us. So we delivered the stover to the plants, they processed it, validated their mass and energy balances and their economics and the quality with the assistance of our market group and our lab at Western to essentially come up with a shadow business plan that demonstrated the commercial viability of a project. So the recommended project that was chosen was Comet. So what I'll do now is just go over some of the observations. Interesting trivia. Had nothing, did not influence in any way our decision-making process, but I thought it was kind of neat. What we found when we looked at these 19 technologies was that 90% of technologies started off with hardwood as their preferred choice of feedstock. And then over time, of course, as they processed the hardwood and different sources of biomass, slightly over 75% of the technologies ended up with agricultural biomass as a preferred choice. One of the important policy decisions that actually stimulated the development of these technologies was the U.S. renewable fuel policy. Did a lot of wonderful things to the development of cellulosic technology, but it also shifted the focus from fuels and chemicals to predominantly fuels. And that's one of the key things that we found out in our technology evaluation was a lot of great technology out there, but half of them were focused on developing fuels, and the other half focused on developing high purity C6, C5, and lignin products. In the early days of development, many of the companies assumed a very low cost of biomass. And I will tell you that was a very poor assumption. As you can see from our experience looking at these 19 different technologies, biomass, delivered cost of biomass, was the single highest cost component in the production of cellulosic sugars. I've heard this saying many times, you can make anything out of lignin except for money. And to a large extent, we validated that. The good news is that there's a lot of interesting technology coming out of there, out of the lignin space. Hopefully, and Mike will get to that later on, we'll be able to make lignin a very valuable commodity in the future. Now, when we look at the cost of production of cellulosic sugars, first is the delivered cost of biomass. Second is the conversion of the cellulose to glucose. And third is the pretreatment technology used to fractionate the biomass. Interesting enough, when you look at the different cost components and the investment in innovation to address those cost components, we have a bipolar distribution. Now, when we look at the products, it's very important. You got to make something out of it. You got to sell it. Based on the work we've done with the various 19 technologies, what we've listed here are in order from highest to lowest, the highest value to the lowest value products. Take note, it doesn't mention volume, right? Volume is very important. Some of these products are very low volume, very specialized markets. And so when you build an entire plant, you have to think about, can I produce enough volume to make it economically feasible to do so? So just because it has a great price doesn't mean it's economic. And again, if you look at where the investment dollars in innovation have been spent in building block derivatives, you see another bipolar distribution. Now, one of the things that was very important to us was competitiveness against the incumbent market. So the incumbent market, as you know, is sugar from, locally from wet mills, globally from sugarcane. So what we did is we made a comparison of of a cellulosic sugar plant and relative to the economics of a corn wet mill. And as you can see, the economics today are not too bad. They're still competitive. I would say as of today, the corn wet mill on average has a slightly better economics. But I think, as we move into the development of this technology and new markets for the building block products, what we fully expect to see is an evolution from the generation 1 today to generation 2, where we will see higher margins for a cellulosic sugar plant that could be better than traditional wet mills. BIC, we will continue with our original mandate to support the first project, Comet Biorefining and the Cellulosic Sugar Producers Co-op, to make their first on-purpose cellulosic sugar plant a success. We're going to help them, help the co-op develop Canada's first commercial scale development of corn silver supply, and then working with others, continue to work on developing technologies, market experience, and using the cellulosic building blocks. As far as the next project goes, we're already meeting with the province of Alberta on April 18th to talk about the next project. We're thinking right now a good candidate for the next project will be in the province of Alberta, taking a blend of wheat straw and wood. We'll see how that goes. And once the plant number 1 is started up and producing on-spec product for a good period of time, we'll look at Sarnia plant number 2 or another plant somewhere else in Ontario. Thank you.